back for another 7 Caillou challenge. This is called 254 Shades of Gray. Sugar Daddy's not trying to go all sexy on you. That is actually the name of this challenge. So what you have to do is, notice they'll give you an integer value as the input, in this case 1. That value corresponds to how many elements should be returned in your array. We see that as part of the contract here, we have to return a string array. And it's going to be populated with these RGB values. This is one form of representing RGB values. You notice there's a hashtag followed by 6, I'll say digits or characters, however you want to look at it. And the catch with gray is that for every shade of gray, each of these has the same value. So notice how the first one's 0, 1, second one 0, 1. It's just repeated, right? And same for 2, same for 3, it's 0, 3, 0, 3. You'll notice when they go over 10, you'll start seeing the hex values. So you get 9, A represents 10. And if you're unfamiliar with hex values, go ahead and review that. It's just a different base numbering system. We know the decimal system based on 10, right? So in this hexadecimal system, there's 16 different characters. They range from 0 to 15 in value. And so obviously with 9, you don't roll over yet. Someone decided we're going to use the letters up to F, right? You use 6 more letters to get 9 plus 6 would be 15, right? So you got 0 to 15. So you'll see A, B, C, D, all the way up to F. When you get up to 0F, then it will roll over to 1, 0. And hopefully you're familiar with this already, but if you're not, you can ask me questions, or you can just look up. I'm sure there's tons of information on hex numbers readily available on the internet. But you'll notice one catch here. Let's go down to our edge cases. If the input is higher than 254, just return an array of 254 elements. They don't really describe why here, but you can imagine for a hex character, which each of these are, they represent 4 bits. And so think about the values 0 through 15. I can't represent 15 with 3 bits, right? If I use 3 bits, that would just, the maximum, the way I could max out would just be 111, which would be what, 7? So you clearly need 4 bits to get all the way up to sort of cover each of these digits. And so for a pair of them, which each color, the red component, the middle 2 are the green component, the last 2 are the blue component. And so each of these, if each character is 4 bits, when I have a pair of them, it's 8 bits, right? And for 8-bit, you have values ranging from, there's 256 values. It'd be 0 to 255. And again, just ask me questions, or just look up sort of numbering systems, binary, hexadecimal, if you still have questions. Anyway, let's get on with the challenge. So basically, well, you know what to do. I'll format this while you pause the video and try it out, and then I'll sort of explain my approach for solving this. All right, so you've had a chance to pause. I'll do a simpler solution where we just I won't use any LINQ, and then I'll do another solution to make it more concise with LINQ. I suppose the first thing we should do is handle the edge cases. So, I don't think they mentioned it here, but if you run the tests, they do try to hit you with negative values, and so we have to handle that. We'll say if n is less than 0, they want you to return an empty string array. I'll just put new string, size 0, just an empty array. So that'll handle that. And then we have this bit where if it's higher than 254, so let's handle that. I'm going to say int num shades is going to be n is greater than 254. We'll say here, we'll set this up. So I'm going to try to keep my good practices going. We're going to not use a magic number. Let's make a max shades constant here. We'll set it to 254. That's what they told us to use as the max. So if n is greater than 254, use that, else use n. And you could similarly write this out with an if statement. If you don't like this syntax here, you could say if n is greater than 254, n equals 254. Or you can use num shades here. I made a separate variable, but you could use n if you'd like to. And so that's good. I know now I'm going to use a loop. I'm going to basically loop through the number of shades. I'm going to construct a string, a hex string, if you will, here. And really all I have to do is do it for one character and then repeat it 2 more times, right? Because in order for it to be a shade of gray, all the R, G, and B components have to have the same value. So I'm just going to figure out one and then copy it 2 more times. So we'll say I is less than num shades, increment I, define some scope here. And let's do it the simple way first, then we'll use LINQ to make it a little shorter. So how can I do this? I could say something like, we could get the individual, say the red component. And what you can do is you can take a value. Notice that we're starting from 1, right? Because they told us, I didn't mention this up front, but black is all 0 and white is all F. And those are not gray values, right? They're distinct colors in their own right. So we're not including those. So that's why I'm going to say I plus 1 here. So my loops, is starting at 0 as we normally do. I'm just going to say I plus 1. But the thing is I want to convert this to a string. And toString has an overload where if you say X, that's kind of like hexadecimal. It'll tell me to convert this integral value to a hexadecimal string and assign it to shade. And then you'll notice we have one other bit. Here, let's step through this. I'm going to add a right line. We'll say shade, shade. But you can imagine as we get the color, we're just going to add it to some string array, right? String array result is what I often use for that. New string num shades. And I'll just say, this won't obviously pass right now, but I'll just do this. I'm just going to step you through this so you can see how we're building the result. So I'll hit test. On line 8 I did something terrible. Oh sure, I forgot to return it, right? Okay, so here's the first part of our problem. Notice this is all looking good, right? We got the RGB values stepping up one at a time for the number of shades that we want, but we don't have this leading 0 that we'd like. And if you've been with me for a while, you know we have this pad left. You can look this up in the string class, and you give it a total number of characters. So note how my string right now is size 1, and what you give it is how many total characters you want. So this is going to add 1 extra value, and then you say what the padding character should be on the left. And in this case, it's clearly 0. So let's see what this does. Okay, that looks a lot better. Now we can sort of combine these, right, 3 times to make the shade. One thing to note too that you may have gotten in trouble, notice that there's this little bit here where me personally, when I work with hexadecimal values, I like capital letters in mine. That's my preference. So if you're in a context where you want that, just note that you can capitalize the X to get it. That's kind of a nice little thing. But in this challenge, you can see expected, they want lowercase. So I'm going to go back to lowercase. I don't like that, but we work for who gives us the job, right? So let's see, that's good. We're going to get our leading values. So now you can imagine once you have this, you can do something like make the total color, right? And it's going to be equal to the pound sign, right? Because all of them start with the pound sign. And then we could say shade plus shade plus shade. And if you're experienced, you know you don't have to do this, but bear with me. I'm trying to make this video accessible for everybody. And then we could simply assign the result to color. And something like this should get us close. And we nailed it. So yeah, you can see we got the pound sign, we got our leading 0 when necessary with this pad left, and then construct it that way. So I'll hit the attempt, make sure it still works there. Good. So made it with me through that. If you want to stick around, we'll see how we can do this with LINQ too. That said, I'll go ahead and bring in system LINQ. All right. So now, I'll just comment out our other solution. Now we can kind of construct this in place. And so the way I'm going to do it is, again, if you've been with me, you've probably seen me use enumerable repeat method. I've recommended to students that you just keep that page, keep a tab open with enumerable so you have all of its methods there until you get really comfortable with them and know sort of internally what's at your disposal. But we can just repeat the character we construct 3 times, right? So let's do something like that. Let's say enumerable repeat, and we can copy. We already did the heavy lifting here. It's the same concept. It's this 2-character representation here. We'll just kind of paste that all in, and we want to repeat it 3 times, right? There's an R, there's a G, and a B value. So that gives us an enumerable of strings as a result, and we need to convert this into just a string, right? The type of result is a string array. It's not an enumerable of string. So we know that we have string join method is great for combining these generic collections that are returned from the LINQ methods. And so I think I need a closing brace at the end. That will give us that part, and then definitely don't forget we need the pound sign to start the whole thing, right? So I'm trying to say here, and hopefully the more you stay with me, the more this kind of reads and isn't confusing, but convert to hexadecimal, pad it left as necessary, make it always size 2 characters, and use a leading 0 if necessary. If you don't need it, it won't put a 0 on it. It's ensuring that you have size 2. And you're going to repeat that 3 times because we have RGB. And then join just means form it all into a string, and since I used an empty string, it won't put anything between the values, which is what I want. Sometimes you want commas or spaces between values. Definitely not here if you remember the results. So assuming I did this right, let's see. Okay, that hits. That hits, good. So yeah, I'm gonna stay with the LINQ solution, but definitely in this 8 and 7 Caillou range, I want you to be able to do these without using the LINQ methods. You know what I mean? They should be a nicety, that a convenience that comes once you're comfortable with the basic building blocks. But that's what I recommend. It's still good for you to see it though. If you are new, it's great to start thinking about. So I'm just going to clean this up a little bit. I'll leave that. Maybe I'll get a best practice vote for this. I think that'll do it. They're going to make me attempt again. Still green. I'm going to fire mine off, and you know what to do. Go through the solutions, see what you can learn from others, maybe do some reading on alternate numbering systems. Binary and hexadecimal are huge in computer science, and even octal to some degree. But yeah, here's some LINQ for PowerLink users there. Yep, similar. String. I like the string format used in these 2 examples. That's good. I wish I had thought of that. But enumerable repeat 3 times, you know, it's fine. I kind of like this one better though, I think. But yeah, you do the same. Go ahead and look through these. Otherwise, you know where to find me if you have questions, and I will see you in another video. Thanks for watching.